I made my own 3D renderer for Geant4 applications. This renderer was made to solve three issues I was having with Geant4 rendering. First, it's hard to set up a Geant4 application with rendering. Second, using the 3D renderer built into Geant4 can cause the simulation to slow down and sometimes crash. And third, using Geant4 in Docker, you can't get any 3D rendering. The reason for this is because Docker on Windows and Mac runs Linux containers in a virtual machine. And so if the Geant4 app tries to access the system's hardware to display something on the screen, it can't because it's blocked by that virtual machine. As someone who loves using Docker because you can ship around containers that work on any machine, it was really frustrating to me that I couldn't get rendering working in Geant4. So that's why I created this renderer, Remora. Remora are little fish that latch on to bigger fish. And that's kind of the idea of my renderer. Instead of integrating it directly into Geant4 itself, it's a separate application that simply connects to a Geant4 application. Under the hood, here's how the Remora engine works. First, you need to add a small server onto your Geant4 app. This server is open source and available on GitHub. The server runs itself on separate threads of execution. This means it can run parallel to the Geant4 app without blocking or slowing down any of the physics simulation. The server exposes a port where Remora clients can connect to. Then the server just waits and does nothing unless you connect a Remora client. The Remora client is an app that can be downloaded on your local machine. It connects to the server through the port and signals that it's ready to receive messages. Then, throughout the Geant4 simulation, data about the geometry and the trajectories is sent to the client, which decodes and 3D renders it. Because the Remora renderer communicates through the network on a port, it doesn't matter if you're running your Geant4 simulation on your own computer, inside a Docker container on your computer, or even on a server somewhere else. As long as you can get the port exposed on your own machine, the Remora client can connect and start rendering. Here's how to try out the Remora 3D renderer right now. So first you need to go to the website remora3dgraphics.github.io and download the Remora client. This takes you to a page of all the releases, and this is the first prototype. It has a few issues, but at least it works. So install the Remora installer, and then follow the instructions to download the Remora client on your computer. Once you've installed the Remora client, it will open up a window like this. Now, it won't do anything until you hook up a server running Geant4. So to try out the demo Geant4 server, we go here to this link, Geant4 server, and view on Docker Hub. So to use the demo Docker server, first install Docker Desktop, and then run this simple command, which will pull the Docker image, start a container, and expose port 8080 so that the Remora client can start receiving those messages. So all I'm going to do is copy this command, open a terminal. So first I'm going to open Docker Desktop in the background, and then I'm going to run that command. On the right, we have a Geant4 app running completely on the command line. To start rendering, first we need to initialize our Geant4 run. So I do that by running the command run initialize. As you can see, the Geant4 app has been initialized. Now I'm going to run the command to send the detectors to the Remora client. So I'm going to type Remora send detectors. Press enter. And now on the Remora viewer, you can see some detectors show up. For now, I have the controls hooked up to the WASD keys and the IJKL keys to move around and rotate. You can also zoom in and out with U and O and adjust the perspective with Q and E. If there's an issue with the client, you can just close it and open a new window. And as you can see here in the Geant4 application, it'll connect another client. So now if I want to run a Geant4 simulation, I can just do that from the command line. So I'm going to do control execute run.mac, which the run.mac file contains a simple example Geant4 run. Press enter. As you can see on the right, the Geant4 application already finished. And the renderer is a little slower, but the nice thing is that this renderer does not block the Geant4 physics engine. So that way, no matter what happens on the rendering side, the Geant4 application can run as fast as it wants. As you can see now, the Remora renderer is showing all the trajectories of the particles. And if you want to clear out all the particles and start over, you can run the command Remora, remove shape with name, TRAJ for trajectory. Press enter, and as you can see, all the trajectories are deleted. You can also change the color. If you don't like this red color, you just run the command Remora, change color, and input your red, green, and blue values. Press enter, and as you can see, you have this nice new color. Another bonus with Remora Renderer is you can have multiple clients running at once. So if I click on this again, as you can see, I have two different clients. I can send the detectors again. And now on the top, I have a completely separate rendering client that will run independently of the one below it. So if I want to show the simulation from two different angles, I can set them up like this and do another run. Control, execute, run.mac. As you can see, they both render the trajectories in their own way. Now, this project is still in very early development, but I'm excited about all the ideas I have for new features, new capabilities of the Remora 3D renderer. If you're interested in the project, go again to remora3dgraphics.github.io, download the Remora client and give it a try. You can also check us out on GitHub, where we have the open source Geant4 Remora server that you can check out. And if you'd like to contribute to this, you can go ahead and check out the contribute document that explains how to contribute to the project. Now, there are more features coming soon, and if you want to support the project, please donate here on Ko-Fi. Thanks for watching. See you next time.